Okay, I think we are able to compare a few understandings. Is that your byte, for example, if you are talking about 1 byte is 8 bits, alright? This is actually an unsigned system, meaning uh, you have no positive or negative. You're only talking about full positive system, if you still remember. So your size 8 bits. So because 1 byte is 8 bits, so the size is 8 bits, and the largest is the lowest is from 0 to 255. Alright. For a short system, I don't know what the hell is that, but it is a signed system, which is 16 bits from negative to a positive value. Alright. So therefore it's just the meaning lah. Alright. For integer, alright, it is a sign also, but it's a 32 bits. Alright, then blah blah. Okay. So I think over here what they're trying to do is just to do in terms of the bits and the integers, the type. So they are all integers over here, as you can see. Over here there is signed, unsigned, signed, unsigned, all over here. It doesn't need to know the unsigned sign. The signed means that you have signed it to have positive and negative. Unsigned meaning that you didn't touch anything, which is just pure positive stuff, which is from 0 to 255. You're taking all the bits are all positive. For a signed system, you break the bits into positive and negative. Or you break them down accordingly. By the meaning that I break them down means that from 0 to a positive value, from 0 to a negative, I break them in two parts. Alright, we call this the two complements, if you still remember. Alright, and you can just read the table, but as you can see, the float over here is either float or double. So these are all the names like you can type inside the Arduino as short or long, but I just want to convey that for long and unsigned long, they are the same. Wait for integer and long, they are the same. Okay, they are the same. Okay, so they are for integer and long, they are the same. For unsigned integer and unsigned long, they are the same. You see? And I think you can see, right? It's pretty clear for you. Alright, so for the red color one, the integer and the long, they have the same values. You see? The lowest and the highest are the same. They are 32 bits, both of them. Alright, so when you do your Arduino, you can actually set in terms of initialize integer, or you can write as long. Alright, for the unsigned integer and unsigned long, then they are also the same. Sorry, yeah, you see? So from here we can see that integer is a signed system, is it? Yeah, integer is a signed system. Alright, so we can see from here, integer is a signed system because it's from negative to positive. You see? There's a negative value to positive. Alright, and therefore for the unsigned is all positive lah. As you can see, it's from 0 to positive value. Okay, so these are the little stuff, and integer is equals to long. It's the same thing lah. That's what it's trying to say. Alright, and I think that's all lah. Okay, and haven't finished yet lah. So let's continue. So they actually run a test using Arduino. They're writing this certain codes. Alright, and execute it 1000 times. I'll not go into details. I don't think it's much. From here you can straight away see that the number of cycles taken for the float is much bigger, taken compared to the integer. You see, these are all integers, these are 4 floats. So the float take in a lot of time and have a lot of cycles in order for more precision. So if you want precision, the float is good, but it takes in a lot of time to cycle. This is the meaning. And the double is just simple, telling you that it is a double precision. The float is a single precision. Okay, so these are the things that you may need to understand. And then they actually use it for the Dewey 32-bit. So you have this outcome. So if you were to use in the Mega, alright, also which is an 8-bit system, you take in more cycles also. You also take in more time. Okay. Yeah. So if they actually compare the dual 32-bit and the 80 mega 8-bit. Alright. So the outcome is that integer arithmetic is more efficient than your floating. Alright. So if your arithmetic is pretty simple, you don't need any precision, you use integer better. Alright, if you're talking about requiring a complex system, then we suggest you use the floating point. Alright, because decimals points, so normally decimal you'll just use floating. Alright, that would be better. Okay, so this says that using the microcontroller's native data size means that the microcontroller, for example, for Mega, the native is the 8-bit, because by itself the Mega is already its own 8-bit. Okay, so if let's say your 8-bit isn't enough, alright, to compute the float, alright, then you may require one more additional memory, additional SD cards. So you require one more module or one more shield. So that this is your Arduino, you require one more, we can call this a module, or you can call this a shield, to top up together with your Arduino, so that it can provide you additional memory to process your float. Alright, so this is the meaning of that lah. Okay, so I think we are like kind of done already. So this is a very heavy subject, arithmetic. Alright, so I shall see you in lecture 8.